Unable to connect. I'll try one more time. Okay. We're going to talk about today something called the average value, which is different than the average. So first of all, I need to define the two so that you understand the difference. All right, when you are talking about an average, just plain old average, the definition of an average is f of b minus f of a over b minus a. Where have you seen that before? It's the slope. It's y2 minus y1 over x2 minus x1. Okay, when we in math are talking about the average or the secant, I'm not talking about when they talking about the mean of something. That's mean, median, mode. That's if you're in stats, that's a whole different ballgame. I'm talking about when we're talking about the average. Then if you're asked about the average value. Okay, so that's what most of your homework is going to be about, is asking you about the average value. That is capital F of B minus capital F of A over B minus A. So we've agreed that capital letters mean what? They do. They mean antiderivative. Okay, and so another way to write this is we use the integral to show that we want an antiderivative. So the antiderivative of f of x dx, and which bound goes where if we want f of b to be first and then f of a to be second. So the a has to go on the bottom and the b has to go on the top. And then we still have over b minus a.
What's the purpose of?
I'll tell you just a minute. Hang on. Thank you. You're always anticipating such good questions from you. All right. So one of the little memory tricks to help you remember this is a play on words that goes like this. The top we call an integral. The bottom is called an interval. I quizzed Emma, that's my college daughter. She took this class when she was here at Valley. When she came home for Christmas and she was laughing, she's like, Mom, I don't remember anything about AP calculus. She's like, I don't need it for my nursing classes. I just don't remember it. And I said, integral over, and she knew it right away. It's like that was one thing that she just remembered. Interval. I was like, see, you remember one thing from AP calculus. Good job. Integral always goes on the top. Interval goes on the bottom. This is what's called the definition of an average value. Okay, Joanne wants to know what this means. I'm going to put a box around this. All right, the best way that I found to understand what in the world an average value means is to picture a wavy function. All right, so imagine that you've got this function and it's going, okay, you've got this. And you want to know what the average value of that function is. So the way I imagine it is I imagine it's like a fish tank and there's waves in the fish tank, right? And the water is sloshing around and it's all crazy. Okay, the top of the surface of the water is violent. The average value represents where would it settle if it was all flat. If all of the water flattened out and there were no rises and falls in the water anymore, how tall, what would the depth of the water be? Okay, and so if we could settle this water and it settled about that tall, so the peaks and the valleys all settled, how tall would that be? That height or that depth is the representation of the average value of a function. That's the best way that I know how to explain it because it's visual and hopefully that makes sense to you. That's what we're going to. So if you're looking at a function and it's got waves and stuff in it, the average value would represent where that would happen. Okay, so let's practice a couple problems where we want to find the average value. All right, what is the average value for the function, let's do an easy one, x plus 3 on the interval 0 to 2. Now this isn't a wavy function, it's a straight function. Okay, this is just a slope linear function. But if we could settle that linear function into something that was perfectly level and horizontal, where would it settle out as? All right, so this is an easy example just to kind of get us going with it. So we're going to set up the interval over the integral. So you need to write out the integral, which would be the bound 0 to 2, the function x plus 3 dx, over the interval of 2 minus 0. So you're going to quick do the mathematical antiderivative, and then you're going to divide by the interval length, which was 2. Okay, integral over interval. And so my antiderivative is 1/2 x squared plus 3x plus c on bounds 0 to 2 over the interval 2 minus 0. The most common mistake is to forget the denominator, should forget the interval 2 minus 0. So when we plug in mathematically, we are going to end up getting 2 plus 6 minus 0 over 2, so it's 8 over 2. So the average value of the function is 4. Okay, so that is the calculus approach to doing that. Okay, here's another example. All right, find the average value for the function the square root of 9 minus x squared on the interval 0 to 3. Okay, so we set up integral 0 to 3 of 9 minus x squared to the dx over the interval 3 minus 0. So you set up integral over interval. All right, now you're faced with the task of finding the antiderivative of the square root of 9 minus x squared. There is a way to find the antiderivative, but you don't know it yet. Okay, it's very complex because you've got a square root and a square going on at the same time. All right, but there's a different approach that you can take that's sometimes easier. Remember, an integral is just really area. So if you're faced with a complicated function, or at least one that's hard to take the antiderivative of, think of what it means visually. What's the shape of the square root of 9 minus x squared? It's a semicircle. And so, in other words, you could do this as a semicircle over the number 3. Just think of it in terms of its area. But how much of that semicircle? Because what are the bounds? Okay? It's only this segment, because I'm only going from 0 to 3. So first of all, the square root means I'm only dealing with the upper half, the upper semicircle, and the bounds are 0 to 3. This is a semicircle of radius 3. Okay, so I need to know, just using geometry, how much the area of the whole circle would be 9 pi. Right, so this would be 9/4 pi divided by the interval of 3, which is 9/12 pi, which is 3/4 pi. So there will be opportunities for you to use geometry to do this. You don't have to use calculus. Okay, don't limit yourself to thinking that you need to always do an antiderivative when geometry would serve just as well. For the previous, could I have done geometry on the very first problem? Okay, what is x plus 3? Right, it's just a linear line, and going from 0 to 2, could I have done that with geometry? Okay, well, let me think. X plus 3 is this line that goes like this, and I'm going on bound 0 to 2. So what could I have done? I could have done it the trapezoidal shape in here and figured out the trapezoid and then divided by 2. So in that case, what would have been easier for you? It's a personal preference. Is the geometry easier for you, or is the antiderivative easier for you? Okay, so I'm not necessarily saying that, it's always clear you're going to use one or the other, but both are viable. And then the strategies to evaluating average value. Number 1, use an antiderivative if appropriate. Okay, if obvious. If the antiderivative is an obvious, easy one, then go ahead and do it. Okay? 2, use geometry. And the geometry, that would be if obvious. So what do you mean, Ms. Viper? It may be obvious to you, but it's not going to be obvious to me. Like, how's it supposed to be obvious to me? I want to go back to the third option, number 3. So what if you can't do the antiderivative and the geometric shape is not a good geometric? It's not a circle, it's not a trapezoid, not a triangle, not a rectangle. Like, what do you do then? Okay. Use FNint. Okay. There will be a section of your homework that asks you, or gives you permission to use FNint. So if the other 2 options don't work, then use FNint. So here would be an example of what we would do that. Okay, find the average value of the function, the natural log of x squared. So I don't know about you, but I don't even know what the graph of the natural log of x squared looks like, at least not off the top of my head, on the bounds 1 to 4. All right, well, that is not something that I'm going to be able to easily take the antiderivative of, because the natural log combined with the x squared. You will eventually, but right now you don't know how to do that. You only know how to do simple things. And I don't know the graph, the shape of that either. So what I'm going to do is set up the integral 1 to 4 of the natural log of x squared relative to the x-axis, and then the interval will be 4 minus 1. In the event that you do use the calculator, you are mandated, you are required to write the integral down. It has to be written physically on paper. So, and then you use your FNint to evaluate it. So this one, okay, if I just type in a math 9, going from 1 to 4 of the natural log of x squared dx, I get 5.090 divided by 4. So that's as much work as you need, divided by 3. That's as much work as you need to show. Okay, you have to write the integral down, and then you may proceed, and then I'll divide that by 3. And so I'll have 1.697. Okay. All right, final thing just to build on this. I don't know if we're going to be able to finish this. We'll see. How far do you have to go between 1 and 4 to get to half the area? All right, there is one homework question that has you do something like this. I'm just going to leave it there and see if you can figure it out. Yes, what? Not good? Well, what's the whole area?
1.67.
No, that's the average value. What was the area? 5.090. So this would be 5.090 divided by 2. And my integral would start at 1 but end at a mystery number, right? A mystery number a of the natural log of x squared dx. That's how you set that up. And your calculator can solve that for you. That's the part you got to figure out.